Hi my friends, let's create the part number 62, which is called tap body, from my collection of 100 parts. The picture of this object is here. As you can see, there is a revolution volume and two flanges. The drawing shows us that we can start with creating this revolving volume without any problem. We consider dimensions from here and from here. The only missing dimension is this one, but this is the square flange, which has a diameter of 68. We'll use this dimension and then we'll create the flange. Okay, dimensions are 41, 30, 37, 25, 30, 42, 50, and on the horizontal for external 9, 76, 17, and internal 2, 10. 10 includes 2, 31, and 22 from the other side. Okay, let's create this construction. The sketch is placed in this plane to be the same presentation. And now external. No, I start from here. Now internal, which is somehow similar, but some steps are here. Close. Closure is not here. This is the point. I draw a line and I apply extend. Okay, this must be coincident with the center point. I draw a line, center line, from the center point to the end, and again I apply coincidency here. Good. 76 is the length. Yes, let's apply this dimension and everything will be scaled. Yes, but not in the fashion I like. Okay, this is 2, as I said before. This is 10, including 2, and this is 31, and this is 22. Good. This is 9, and this is 17. And now diameters 68, and here 42. Good. Internal. This is 41. This is 37. And to internal 25, and fully constrained. Finish sketch, revolve. This is the main body. Okay, let's place here a flange, which can be a polygon with 4 sides, and dimension being this internal, to create this, and make horizontal one side. Finish sketch. The extrusion is the same, has the same thickness with this, so I extrude only triangles. How can I call them? In the other direction, join 2, and I'll show this face. Yes, not any dimension was necessary to be placed. Radius 8 of the fillet, 8. Every corner with 8. Okay, then we continue with the bottom flange, which is at the same level with the side of the square flange. Yes, these are on the same line. The dimension is 13, the thickness, and dimensions are here. 80 the distance, radius 14, and radius 27.5. The distance is 27.5. Then this is finished right here. Yes, the tangency will be here. Okay, let's create this flange. I change the view because I want that flange to be here, and I draw a circle with the radius of 27.5 radius, another one with the radius 14, and another one. I apply equal to make them equal. I place on the same horizontal. Yes, this is that plane, the same horizontal, this point with this point, and the other with the middle circle. Okay, now I apply tangent, click here, keep pressed, and look to see the tangent mark. Yes, keep pressed and find the mark of tangency. Okay, very good. Equal these two, and now I can trim these two, nothing is loosed, and I have to apply split for at least one arc in order to change to construction and to maintain this dimension. It is only now that we apply the distance. This is a good strategy because the circles could be intersected and then to have problems. The same vertical for this point with this point, and the distance of between this circle and this point or face of 27.5, which means that there is a tangency here, but we use dimensions in the drawing. Finish sketch, F6, and now extrude on 13, the other direction, join 13. Okay, nothing is disturbed inside. Yes, you see. Now there is a number of fillets, radius 6 here, radius 4. That's all. Yes. Oh, there are 2, 2, 2 inside. Let's apply to the inside because it is the difficult one. Is this, another this, and the last is this one, 2 plus 6 for this, 6, and the other also 6, plus this one, which is 4. Okay, now holes. The main hole is this one, which is a specific diameters of 26 to this end, 120 and 43. Hole of this kind, countersink on this face, centered on this contour, and then let's apply dimensions. Tab. The depth is 2, and we select this internal, tab 4 millimeters is 43. Tab 90 is 120. The angle of end, and now 26. Okay, you see, very nice. We can look inside, you know how, by using a trick, and this is the internal. We don't have here a section of this kind, but we see that this hole is very near this line. Yes, there is a small distance between these two. Okay, Control Z. I don't create that sketch. Now the other holes, two holes of 14. This face, I project the symmetrical one. I mark with points, and then hole, simple hole through of 14, and both holes are created. Okay, now there are some other holes in this face, which are two holes M8, metric 8 through, and two holes with a depth for both thread and hole of 9. Yes, two are in the air here, and two are not outside. Okay, hole threaded, ISO 8 through 1, 2. I repeat this creating of a sketch, hole with points, but not through, a distance of 9 to this both holes. This is the part, my friends, nothing else. We can verify, but nothing is to be added. Yes, that's all. Okay, steel cast, steel cast, and some faces to be machined. I suppose that all this must be machined, also this, and the face of the flange, the conical face, and that's all. Let's apply also to these holes to be okay. Polished. Data. A small part of 1 kilogram. That's all for the moment. Thanks for watching. Bye bye.